FDNY Firefighter Manual, Chapter 3, FDNY Apparatus. To familiarize members with the apparatus used in the FDNY. Contents: engine company apparatus, ladder company apparatus, rear mount derailleurs, tiller derailleurs, tower ladders. Source: FDNY Tactics and Procedures, FDNY Training Bulletins, FDNY Saver Training Manual, FDNY Reference, FDNY Tactics and Procedures, Ladder 2, Ladder 6, FDNY TB Apparatus, FDNY CBS Engine Reference Manual. Part 1. Engine Company Apparatus. Section 1. Introduction. 2. Basic pumping operations. 3. Pump controls, pump panel and supply. Discharge options. Conclusion. In carrying out its mission of fire protection and response to countless types of emergency, the FDNY utilizes several types of apparatus. Since circumstances can develop at an operation which requires quick and decisive action, it's necessary for FDNY members to have an understanding of the apparatus in service. The two basic units of the FDNY are the engine company and the ladder company. The following chapters will introduce the primary apparatus of these units. The first section will focus on engine company apparatus. Part 1. Engine company apparatus. Introduction. The function of engine apparatus operated by the engine company chauffeur is to deliver engine company personnel, hose, appliances, and assortment of tools to the scene of an operation. Additionally, this rig is to be positioned to utilize the various available sources of water and pump the water needed in operations. FDNY engines carry an onboard supply of water, but this supply is only enough to start operations at an involved incident. Since utilizing properly positioned hose lines, which are supplied adequately and operated efficiently, is one of the major factors to a successful operation, it is essential that all members have an understanding of pumping operations and how to use the pump of an FDNY engine. Although the FDNY employs several manufacturers and models of pumpers, the same general procedures apply in pumping operations regardless of make or model of apparatus. Basic pumping operations. The function of an engine in pumping operations is to function as the pump. Water is taken from the source of supply and delivered through a hose to a point of operation or to another apparatus. To ensure adequate flow, predetermined pressure must be delivered to the point of operation. In order to avoid computation of complex mathematical formulas at a fire scene, simplified rules of thumb or street hydraulics are used to determine required pump pressures. The sizes of hoses used by the FDNY and the desired flows to achieve an effective stream are as follows: 1 3/4, 108 GPM, 2.5, 225 to 250 GPM, 3.5, 400 GPM. To achieve the above desired flow, the pump must deliver a pressure which will provide the necessary pressure at the operating point. To do so, the pump must provide pressure which will compensate for the effects of gravity and friction in flow reaching that operation point. Factors which influence the necessary pump pressure include the amount of water being pumped, diameter of hose, length of stretch, any appliance attached to the hose, for the nozzle, the type, inlet diameter, and tip diameter, desired nozzle pressure, elevation. Pump control, pump panel, and supply discharge options. In order to operate the engine at a pumping operation, it is necessary for the pump and operator to have an understanding of the pump and be familiar with pump controls and pump panel, as well as various supply and discharge options. Most pumpers in the FDNY are two-stage pumpers. This means that there are two impellers, and the operator has the ability to operate these impellers in series or parallel, depending on the needs of the operation. All pumps are driven by the engine drive shaft. When setting up to pump after positioning the apparatus, the ECC switch, the pump shift, and the cab from the road position to pump position. The steps in this process are as follows. Upon positioning the engine, switch transmission to neutral. Engage maxi brake. Transfer pump shift from road to pump position. Switch transmission to drive. Properly completing the above procedure effectively switches the drive shaft from powering the drivetrain to the drive of the pump impellers. The ECC is now ready to flow water and regulate the discharge pressure. Note, if the pump is not engaged properly, the only pressure that can be discharged is the supply coming into the pump. To flow water, it's necessary to have a supply of water. This supply can be one of the following: connection to a hydrant, drafting, supply line from another apparatus, booster tank water. Photo 3.2 shows a typical pump panel which ECC would operate. Chapter 3. Intake pressure, master pressure, pro pressure governor, booster tank fill, booster tank gauge, tank to pump valve, prime valve, transfer valve, inlet throw, discharge and drain. The intake gauge indicates the pressure of the water supplying the pump. With no water flowing, this is static pressure. When water is flowing, what's indicated is residual pressure. As more water is pumped, i.e. additional lines, this residual pressure drops. When residential pressure drops below 15 psi, augmentation of the water supply is required. Master pressure gauge indicates the pressure of the pump is putting out, equal supply pressure plus pressure imparted by impellers. Pro pressure governor, computer which controls engine RPM and consequently the discharge pump pressure. As the throttle, this control brings up pump RPM to deliver the desired pressure. As the governor, this control over RPM maintains pump pressure so that hand lines do not receive pressure surges when nozzles on other lines are opened and closed. On older engines which do not have this governor, those engines instead have a manual throttle which is used to set pump pressure. Additionally, these older engines have a Ross relief valve which, when set, prevents pressure surges. Booster tank fill, a valve which, when opened, allows some of the incoming supply of water to be directed through piping to fill the booster tank, which on most engines is 500 gallons. Booster tank gauge provides illumination of level of water in the booster tank in quarter increments. Tank to pump valve which when opened allows contents of booster tank to flow to the sudden suction side of the pump. Prime valve operates a prime pump to inject water into the pump chamber. Doing this expels air from the pump chamber, thus enabling the pump to generate the necessary suction to operate. Priming the pump must be done at any hose line operation before increasing pump pressure and opening any discharge outlets. Transfer valve. Position of this valve determines whether the pump impellers work in series pressure or parallel volume. When the transfer valve is in pressure position, all water flow is directed across one impeller with a discharge directed toward the second impeller. Effectively, the pump discharges two bumps in pressure, therefore it's possible to quickly develop pressure in discharges off the pump. However, because the pump discharges off one impeller, all flow is from the second impeller, the volume for higher flows is limited. In the volume position, the incoming flow is split. Some incoming is directed to one impeller, and the rest is directed to the other impeller. The discharges of both impellers are joined to create the overall pump discharge. Effectively, in this configuration, the pump discharge has had only one bump in pressure from either of the impellers, and therefore takes longer to develop discharge pressure. However, because the discharge is from two impellers, higher flows are possible. Important. Standard operating procedure is to pump in the volume position. Only in an operation where head pressure are to be overcome, i.e. standpipe operation, should the transfer valve be changed to pressure position. Inlets. Most engines in service in the FDY have 5 inlets, 3 4.5 inlets, and 2 3 inlets. Gated inlets are those which have a valve between the inlet connection and the pump chamber. One of these inlets is used, the valve must be fully opened in order to ensure adequate supply to the pump. Flow through the inlets are those which have no valve between the pump chamber and the inlet connection. These inlets must be capped when not in use. Discharges. Most engines in service in the FDNY have 6 discharges plus a desk pipe. These discharges are numbered 1 to 6, starting with the front discharge and proceeding counterclockwise around the rig. These discharges are also color-coded. 2 of the discharges are 3, and the other 4 are 2.5 discharges. Conclusion. In assigning the engine company position of ECC, most engine companies assign a senior member or at least a member with additional training regarding apparatus safety and pumping operations. All members must realize that this does not preclude the rest of the ranks from having basic knowledge in pumping operations. At an accident, it's not inconceivable for an ECC to suffer an injury serious enough that he can't initiate or continue a pumping operation. In this case, another available member would have to step in and either initiate or continue the pumping operation, because regardless of the situation in the street, the operations in the fire area must continue. It's been proven throughout the history of the FDNY that the most effective life-saving tool is a properly positioned and adequately supplied hose line. Part 2. Ladder Company Apparatus. Introduction, Terminology, Aerial Ladder Use, Tower Ladder Use, Conclusion. Part 2. Ladder Company Apparatus. Introduction. Until the 1970s, the New York Fire Department had placed primarily reliance on the use of aerial ladders as an exterior means of access to the upper floors of buildings. It places full reliance on the metal aerials for developing elevated, larger caliber streams when the water towers were phased out. Today, almost 60% of our ladder companies are equipped with metal aerial ladders. The remaining companies have tower ladders. The two types of aerial ladders apparatus currently in service are the rear mount and the tiller. Both types are equipped with a 100 aerial ladder. The difference is that the tiller is a tractor trailer rig with a maneuverable rear wheels. This allows for easier maneuvering around in tight turns. Rear aerial, tiller aerial. The third type of ladder apparatus is currently in service is the tower ladder. The tower ladder was introduced to the fire service several years ago. Its full potential is still being developed. The effectiveness of this apparatus in ladder company operations on the exterior of buildings for access to the interior and for rescue purposes is without question. In addition, it also provides a superior elevated large caliber steam capability. Terminology. Tormentors. Hydraulic supports which direct frame attachment. When lowered and locked, each becomes a rigid member to provide a rigid operating base bypassing the apparatus suspension. Rear mount. Two tormentors adjacent to the turntable at rear with controls on rear of the apparatus. Tiller. Tormentors adjacent to turntable at center apparatus, front trailer section. Controls are on pedestal. Tower ladder. Classic, supported at 6 points. Jacks, one at each corner of apparatus. Outriggers alongside the turntable. Aerial, 100-foot, 4-section ladder made of corten steel. Bed ladder is base section, which is fixed, does not extend or extract. Upper 3 sections are moving, sliding sections. Each section has a handrail, which tapers to beam at top. Rungs. Cross members between beams, which are used for climbing. Rungs are spaced 14 apart. Turntable, pedestal, platform at the base of the aerial or tower ladder. On an aerial ladder, this platform is used to mount or dismount the aerial. On both aerial and tower ladders, the turntable contains pedestal controls from which the operator can operate the aerial or tower ladder. Aerial ladder use. Aerial ladders may be used to effect lubbers, ladder pipe operations, observation post to assess conditions, ventilation member on ladder, lower tip through window, entry, rescue, search, LOVERS, ladder pipe operations, observation post assess conditions, ventilation member on ladder or lower tip through window, entry, rescue, search. LOVERS. L. Ladder pipe operations. O. Observation post to assess conditions. V. Ventilation member on ladders or lower tip through window. E. Entry. R. Rescue. S. Search. They may also be used to stretch hose lines to upper floors or roof, bridge a gap, and operate hose lines from the ladder. When their need is evident upon arrival, they should be raised immediately. When their need is anticipated for later use, the ladder shall be positioned and set up. Apparatus setup and operation. In cab engage power takeoff, PTO, to transfer power from the drivetrain to powering the apparatus, support and aerial controls. Once apparatus is in position, place transmission in neutral. Engage maxi brakes, rear brakes, push to apply. Engage brake lock, front brakes. Flip to on position. Place transmission to drive. Flip PTO lever to IN position. Return transmission to neutral. Look for PTO light illumination. Place the throttle switch to on position. Note on some apparatus this switch may be on the pedestal. Aerial control panel operations. Item. Stabilizer, not nested light. When lit indicates stabilizers are not completely retracted into the body for road travel. Aerial horometer, hour meter, indicates total hours aerial has been operating. Hydraulic system indicator light indicates when hydraulic filter should be changed. PTO light, when lit, indicates PTO is engaged. PTO control switch, used to start-stop PTO for aerial hydraulics. Front brake light, when lit, indicates front brakes are engaged. Front brake lock switch, used to set front wheel brakes during aerial ladder operation, not to be used for parking. Auxiliary pump light, when lit, indicates auxiliary electronic hydraulic pump is activated. Normal emergency hydraulic switch, selects normal PTO pump or auxiliary electronically operated pump. Generator switch and run light. Switch to activate generator light on indicates generator has been turned on. Stabilizer controls. Also called tormentors. Hydraulically operated H-frame stabilizer tormentors are located behind each rear wheel. The controls for these tormentors are located in rear compartment stabilizer control compartments, one control handle for each side. On trillers, controls for stabilizer tormentors are on the pedestal. Tormentors can be placed in operation by one man pulling the handle out slightly toward the operator and into down position one side at a time. Before operating tormentors on rear mount apparatus, check for 5-2 clearances at each side and ensure that the area on operating side is clear of members, civilians, hose, or obstructions. With hand-on lever, it is possible for a member to view tormentor in motivation. This is not true for all members, however, due to differences in individual reach. If a member cannot view tormentor in motion with one hand on lever, he will proceed to lower tormentors by placing lever in down position. Lever will remain in down position unattended. Momentarily step to side and witness tormentor in motion until operator determines tormentor is properly positioned. Lever is returned to neutral position at the moment. Repeat procedure from other side. Shifting the feet a few inches as described above will permit member to operate efficiently without sacrificing safety. Under extreme emergency condition, where both tormentors cannot be lowered due to obstructions, it is permissible to lower first the tormentor on the side of the apparatus that ladder will be used. The other tormentor shall be lowered as soon as practicable. Before leaving control, be sure both handles are in neutral. Engine speed must return to idle. Operate aerial, raised bed ladder. Depress aerial enable foot switch on the base of the pedestal. Raise the ladder by pulling back slowly on the hoist lower level. Release hoist level lower level when sufficiently elevated. Rotate ladder. Depress aerial enable foot switch at the base of the pedestal. Rotate ladder by moving rotation lever as required for proper direction. Release rotation lever. The ladder has reached desired rotation. Extend fly sessions. Depress aerial enable foot switch at the base of the pedestal. Push the extension reaction to lever to extend the desired length. Release extension reaction lever when ladder has reached desired length. If possible, make sure rung alignment indicator is light on before permitting personnel to climb ladder. Placing ladder. Depress knob on top of bed ladder control and push handle away, directing ladder toward objective. Return handle to neutral position when underside of beam is about 2 to 6 from the objective. It is expected for the weight of the men climbing ladder will place ladder in the supported position. Aerial ladder placement. To the roof. Extend the ladder to that tip of at least 5 feet above the point where the ladder comes in contact with the building. To a window. Placement must allow for unimpeded access and egress at that window. Therefore, the ladder tip should be less than 6 over the window sill. Recommended distance from the tip to the objective is 2 to 6. In case of rescue, use 2 positioning so that the ladder will be resting against the window until after weight is put on it. Alongside fire escape, against the building, 2 out, with the tip about 1-3 feet above the balcony railing. This affords easier access to the ladder. Remember the loss in height resulting from the retracting ladder to apply ladder locks. Climbing and descending the aerial. Coordination. Always face the aerial when climbing or descending. Eyes should look up or forward. This will provide better balance. Avoid looking down. If necessary to look down, look over shoulder without leaning backwards. Hands. Must have one hand in contact with the aerial at all times unless secured to an aerial with a leg lock or the personal harness life belt hook to rung. Hand movement should be coordinated with foot movement. Left hand with left foot. Right hand with right foot. On steep angles, it may be necessary to grab rungs. Feet. Stand on the rung with ball of foot, avoiding driving heel of boot into rung. Each foot positioned to avoid cable. Body position. Body should be perpendicular to ground to allow for best balance and best support of weight carried. Climbing too close to the aerial will impede climb. Leaning back will cause too much weight to be supported by arms, and you are more likely to fall. Dismounting the aerial. Stop climbing at roughly the 3rd rung from the tip and keeping the left hand on the handrail. Transfer the right hand to the rung near the left beam. Pivoting on the left foot, lean to the left to butt right shoulder to building with head and body outside the window. Right leg is brought up and over the right side of the handrail so the climber is now straddling the top rung and facing left. Left hand is moved to the rung, palm down. Right hand is then turned so that the top rung is grasping in a trapeze fashion. While maintaining grip on the top rung, both hands bring left leg into room and gradually ease the weight over the still into the room test floor areas. Let go of the aerial only when certain that floor area is secure. Mounting the aerial from a window. Place left hand on top of right handrail, facing the aerial. Grasp the top rung with the right hand, palm up. Swing left leg out of the window to second rung. Straddle top rung, then shift weight to move left foot to third rung. Pushing up with left hand, pivot body on ball of left foot to swing right leg and put right foot on third rung. Place right hand on right handrail, facing the aerial, and begin descent. Dismounting the aerial at roof. Stop climbing at rung nearest top of the parapet. Bring both feet to the same rung. Grasp handrail to dismount side of a baseball grip and bring feet together. Maintaining grip, bring outboard foot to parapet and test stability while supporting the weight with the leg still on the aerial. Bring the other foot off the aerial to the parapet. Move outboard hand to underside of rung, then follow with the other hand. Supporting body weight with two hands, test integrity of roof with feet. Do not release body weight to the roof until assured that the roof is secure. Mounting aerial at the roof. Grasp overhead rung, place feet on parallel pull-up. The step is not necessary if there is no parapet or cornice. Move grip from underside of rung to baseball grip on handrail. Turn body to face roof. Place one foot then the other onto rung level with parapet. Bring hand to the other handrail and begin descent. Operations for removal of victim or victims by aerial ladder. Never remove people via aerial ladder when they may be calmed and held safely at the location, or remove via a safer means of egress. The preferential order for removal of people is via interior stairs, horizontal exits, fire escapes, ladders, life-saving rope. Observe the building continuously while chauffeur is operating the ladder. Someone may appear at another window, or a trap person may move to another location. Prepare for a rapid ascent, as the trap people may attempt to climb onto the ladder without assistance. Climbing the ladder while it is being extended or retracted exposes members to severe injury and may jeopardize the rescue effort. Ascend the ladder, followed by the chauffeur. Climb into window and assist victim out feet first to the chauffeur and then search the area. Firefighter must realize that other victims may be inside and the victim may be unable to inform him about other occupants. Note: the chauffeur following an ascent on the aerial will keep the chauffeur close to the controls. Only in an extreme emergency, such as direct exposure to flame or great heat, will a movement of the ladder with the firefighter and the victim on it be justified. Always carry small children down ladders. To descend with an ambulatory victim, place yourself one rung below the rung the victim is standing on. Descend in unison, i.e. right foot for right foot and left foot for left foot, keeping the victim between you and the ladder at all times, and maintain physical contact with him. At steeper angles, have the victim grasp the rungs. This will facilitate your control. Talk to your victim. Constantly reassure the victim and praise his actions. Try to talk to him into looking straight ahead or up, not down, as he might freeze on you. If the victim panics, take control by pressing him against the ladder with your body. Do not resume the descent until he is capable of continuing. If the descent is difficult or tiring, another firefighter should back up the member carrying assisting persons down the ladder. Removal is not considered complete until he has been assisted all the way to the ground. Do not leave him on the turntable. If required, render first aid until relieved. Assist him to ambulance if necessary. These actions shall not be taken if you are needed to assist in additional rescue operations. When there are two victims to be removed, the order of removal is dependent on variables difficult to predetermine. In many instances, one of the people will have climbed out of the ladder before a member has reached his position, and there will be no need to make preferential determination as to removal. Occasionally, one of the occupants will be aged, infirm, extremely heavy, or hysterical, and other one ambulatory and less trouble to remove. The removal order should be based on the length of time needed to completely effect this rescue, and the seriousness of exposure to victims and members. A serious fire in the front might cut off a ladder descent in a short period of time. Both members assist the most helpless victim onto the ladder, and the chauffeur assists the victim below the point of danger and then to the street. While the chauffeur is slowly descending, the OVM climbs onto the ladder and assists the more ambulatory person onto the ladder and complete descent is made. In the instance time, the primary consideration in effecting the complete removal of victims below the danger point is preventing the possibility of your retreat being cut off. A serious fire in the rear, cutting off interior descent and no available front fire escape presents another problem. Since the fire is not pushing out the front windows, the time required to effect removal of victims is less critical. In this case, consideration can be given to the simple removal first, and then concentrate on the difficult removal, which will require 2 members. The tower ladder use. General features of tower ladder. Stabilizers support. The chassis is supported at 6 points while the boom is in operation. 2 hydraulically operated jacks are located at the front and 2 at the rear of the vehicle, total of 4, and 2 outrigger type jacks in the middle of the apparatus. All supporters have a direct frame attachment to bypass the apparatus suspension and provide a rigid operating base. With the stabilizer supports lowered for boom operation, hydraulic holding valves lock the fluid in each cylinder, and thus each cylinder becomes a rigid member to support the apparatus under all conditions of operation. To eliminate any possibility of stabilizer support, collapse brought about by loose of fluid from a cylinder or mechanical lock, it is also provided at each jack and outrigger. These locks pins must be inserted manually. All jacks and outriggers must be lowered until each reaches the end of its stroke before raising the boom. Tower ladders are not designed to operate with outriggers and jacks down on one side only. Exemption: if apparatus is not level, lower jacks and outriggers on the low side first, then the jacks and outriggers on the high side until the unit is level as possible. Note: raising the high side fully before raising the low side, or raising only one side when on level ground, can cause damage to the suspension system. Outriggers can easily be placed between parked cars when necessary. Jacks and outriggers must be on the firm ground and locked. To judge that outriggers will clear all obstructions, a 6-foot hook may be used as a gauge. 2 ladders have indentations in the turbo table to accept outriggers. This necessitates that outriggers must be moved clear of the turntable before operating in boom, and boom must be returned to its original position. Turntable arrow markings aligned before outriggers are bedded. Any member operating a tower ladder must personally verify the placement of all triggers and jacks prior to raising the boom from a bedded position. If a member commences to set up a tower ladder apparatus for an operation and then decides to abort the operation, the member must properly place all outriggers and jacks for operation, or return all outriggers and jacks to pre-setup position. Boom assembly. The boom assembly consists of 4 box sections which telescope within each other. The first section is alloyed steel, and the 3 telescope sections are aluminum alloy. The extension mechanism consists of 2 double-acting cylinders which provide power and extension and retraction. The boom hydraulic system has hydraulic holding valves which will prevent the boom from moving in the event of hydraulic line failure. Basket. The basket is constructed of alloy aluminum and the floor area of approximately 15 square feet, permanently mounted on the front surface of the platform in a Stang intelligent nozzle, permitting flexibility in the water tower operations. The underside of the floor and the front railing of the basket may be covered with a fire-resistant shield. Pedestal controls, turntable. Whenever a tower ladder operation is in progress, the pedestal position must be staffed. This provides an extra pair of eyes to warn the impending danger, and override basket controls in an emergency. 3 controls similar to those on a metal aerial ladder are provided on the turntable. These controls are for raising and lowering, extending and retracting and rotating the boom assembly. Operating controls at the pedestal allow for smoother positioning than the controls in the basket. Master power switch supplies electrical power for the master control valve, master console panel lights, engine start, dead man control, and platform basket controls. Engine start button allows engine to be restarted in case of a stall from the master control console. Platform control basket activates the basket control station. Dead man control. Depressing the foot pedal at the base of the console pedestal activates the system and the engine throttle control. This movement also deactivates the basket controls by activating the hydraulic system in case of electrical failure. The use of the platform control switch is necessary whenever members or civilians enter or leave the elevated basket. This is to ensure against movement of the basket by accidentally touching the platform control handle. Caution. There is a possibility that a malfunction in one or more of the 3 boom movements, e.g. lower raise, extended retract, 3 rotation, can occur without being in control of the tower ladder, causing the elevated boom basket to move in the direction of the malfunction. The release of either of the dead man control's foot switch on pedestal trigger or basket assembly will immediately halt all boom movement. In the area of the base of the boom and turntable, there are 3 sets of manually operating isolation valves, 1 pair for each hydraulic circuit, 1 raised lower, 2 extended retract, 3 rotation should one of these 3 control valves malfunction for any reason. The isolation valves for the particular function can be closed, leaving the other system operable. Accessories. Controls light, a master console, front, and optional accessories. Pressure gauge indicates system pressure during operation. Communication switch controls intercom system between basket and pedestal. Basket control single-handed controls all function with dead man trigger on the handle, which must be depressed before the system operates. Intercom open circuit controlled from pedestal. Escape from basket. When no other solution is possible, member may escape from the basket by means of the fixed telescoping ladder mounted on the top of the boom section, or by life-saving rope in conjunction with the personal harness, whichever is more appropriate in the situation. Note: there exists, under some conditions of partial elevation and extension, a possibility of boom section adjustment, gradual shifting with one section extending and another section retracting the same distance, with no effect on the position of the basket. This results in rungs moving in relation to each other. Because of this possibility, utmost caution must be exercised while using the escape ladder. Water system. Boom rotation permits water system coverage of 360 degrees. A specially designed water manifold is located on the rotation axle. The water system consists of 4 telescoping sections of stainless steel pipe operating through conventional U-cup seals and pecking glands. Diameter of smallest sections 3.5. Suitable swivel elbows fitting the additional pipe connect this telescoping system from the basket-mounted stang through the rotating swivel in the substructure to waterline connections on either side of the apparatus frame. Water system hookup consists of a 3x3 gated Siamese on the left side of a 4.5 inlet on the right side. Note there are various Model TLs in the field, and companies involved must refer to their manuals for specifics. Communications. The TL is provided with an intercommunication system allowing for basket to pedestal communications and vice versa, which is the most effective means of communications between basket and pedestal. In some models, the basket control man faces the opposite direction in relation to the pedestal man. It is for this reason that the reference point is the pedestal and not the basket position. When the basket is being controlled from the pedestal, it is most important to keep the pedestal man informed regarding the results of the basket movement. Directions to the intercom must be utilized whenever the need arises for accurate, steady movements. Since the pedestal controls allow smoother movements, the pedestal man should in most cases perform delicate operations if visibility permits. Emergency operations dealing with strategic action and tactical usage of TL require instant communication between officer in command and members and basket. Most effective means is to have a man in the pedestal monitor all the handy-talkie communications and relay orders or other pertinent information to basket via intercom. Handy-talkie is difficult to hear due to noise in basket, especially if stream is in operation. By monitoring the handy-talkie transmissions, the pedestal man can be continuously aware of the changing fire conditions, location of other units during operations, orders issued by officer in command of fire company officer, or any information regarding safety or members and fire extinguishment that will affect TL operation. He can relay these communications via intercom to basket or from basket to officer in command of operations should handy-talkie at basket be ineffective. In the event of failure of both intercom and handy-talkie communications, unit should be preset plan by which pedestal man can relay orders of information vocally or by hand signal, or tap boom with tool, or move boom slightly to attract attention to the pedestal. General General precautions. Where are we? For relief of basket man during extended periods of operations or overhauling, the use of escape ladder shall not be resorted to due to possible rung movement. Detail members cannot operate on pedestal unless they are presently assigned to tower ladder unit or are qualified shuffler tillersmen, QCT school trained. No member shall operate in the basket unless he is wearing the installed safety belt or life belt or personal harness which is secured to a substantial part of the basket. If this is too confining, it is possible to provide working room for by forming a loop 1 foot in diameter and a life-saving rope around a substantial part of the basket, using the bow line to secure the loop, then hook the life belt or personal harness onto the loop. Positioning of apparatus. General placement depends upon conditions encountered on arrival. The officer in command of a fire should give specific instructions regarding the placement of apparatus, and the operations to be performed in the absence of a superior. The TL officer must base his decisions for placement of TL on the following conditions: what wall to work on, based on the life factor; fire conditions, location and extent of fire; type of occupancy, time of day; type of structure, height and area. Remember height limitation with TL. Street conditions, traffic encountered, overhead wires, trees; location of pumper and hydrants; conditions and stability of building; ground stability. Generally, the apparatus should be parallel to the building. Occasionally, the scrub area of the bucket will be reduced by the cab of apparatus. Scrub area is defined as the area of a building wall which can be touched by the basket. This condition can be corrected by parking the apparatus with the front angled about 15 degrees from the building line. This will put the cab portion of the apparatus further away from the rear portion, and this way the boom can be operated to full extent of its scrub area. Regardless of initial placement, it must be realized that as conditions change, repositioning may be required. A properly positioned TL provides wall coverage from grade level or below up to maximum basket floor elevation at the maximum 75-degree angle. The basket, while touching a point 32 feet horizontally from center of turntable, can reach a basket floor elevation of 65 feet. TL scrub area covers the front of a building 60 feet high and 50 feet wide, and will cover a 100-foot frontage on the lower 3 floors of a building. It has a scrub area of approximately 7,750 square feet, with the center of the turntable is 32 feet from the building wall, and cab is at 15-degree angle of the building line. The basket can reach points 10 feet below grade. Positioning on hills. Positions apparatus parallel to the direction of slopes of the boom operations will be in the uphill direction if possible. Apparatus should be facing downhill, e.g. facing downhill turntable past the objective. Facing uphill turntable before objective. All operations of boom should be performed at low speed and delicately while on steep inclines. Sudden stops and maneuvering can cause damage to apparatus and or cause apparatus to skip downhill. Sudden starts and stops. Noted, sudden starts and stops should be avoided under all operating conditions. Use of towel ladder for rescue and removal. The full capability of the TL can be realized when there are many persons to be removed and or victims are unconscious, incapacitated, or obese. Rescue by a basket is effected in several ways. Entering and exiting the basket shall be through the double-acting swing gates. Initially, the basket is elevated to a point where the middle railing of the basket is level with the window ledge or level with the top railing of the fire escape. Middle basket railing positioning permits placement of basket flooring at a level where a person can easily step onto it without the usual straddling of a window, sills, or fire escape railings. To facilitate removal of incapacitated or obese victims, position the top basket rail level with the window sill or stop rail of fire escape. Positioning of basket must be such that the stang nozzle will not interfere with the rescue operation. This will require an angular approach that will permit ease in entering or alighting from basket. Parapet-less roofs can be safely approached by actually placing the basket directly on the roof, if possible, especially when ice conditions are encountered, to effect removal of persons trapped thereon. The many tips of the basket are required to remove a great number of occupants. Safe removal need not necessitate delivery directly to the street level. Occupants may be placed at lower levels of the fire building or any other area of refuge. Tower ladder stream operations. Authority and responsibility for use of TL streams. Only the officer in command of operations may order the use of TL streams. Large caliber outside streams generally should not be directed into occupied buildings. Members must be warned and occupants be removed before starting water. However, in some circumstances, fire conditions or life hazards may demand such use. Examples: fire extending via cocklift and top floor unattainable. A stream, preferably fog, used as an acute angle to building, used to protect people on the fire escapes because fire is emanating from windows below them. In the event hand lines cannot advance due to fire conditions, a fog stream into floors of certain type of occupancies where many windows are accessible. A rapid traverse from window to window affects a quick knockdown of the fire. Use of fog reduces structural and motor damage. The air movement resulting from large caliber stream must be considered. This air movement effect of the stream will drive heat and combustible gases into uninvolved areas of the building. Employment of streams. Development requiring the use of TL streams shall be anticipated. Participation of such usage shall be made as early as possible. When a fire building is heavily involved on several floors, heavy stream delivery should generally start at the lowest level and work upward, effecting a quick knockdown on the way up to the top floor and or cockloft area. Prevention of fire spread upward or extension via cockloft is the prime objective. Positioning nozzle close to and below the window will ensure opening ceiling with stream to expose fire area or cocklift and extinguish fire therein. Operating into cocklift or extreme from party wall of most serious exposure towards center of building, then from party wall of other exposure towards center or roof opening. Maximum steam penetration. Good deflection off ceilings and walls. In a extreme situation, the stream through attic window of peak frame dwelling can be used to ventilate by literally blowing off the roof. Removal of partitions of steam and or removing stock to reach set of fire. Initially reduce members in basket being exposed to escaping heat at higher level of window operations. Primary consideration must be given to the safety of members, particularly in commercial buildings. The TL should be positioned and boom maneuvered in such manner that damage from failing cornices and collapsing buildings will be avoided. When stability of the building is in doubt, the basket shall be placed at least the same distance horizontally from building as well as vertically below the top of the wall to minimize the effects of failing materials. Water delivery. For optimum effectiveness of TL streams, the following guidelines are to be considered. Supply water to base of TL at 200 to 250 psi. Satellite water unit is the best source of supply if available with large diameter hose used. Relief valve of TL should be set at 250 psi. Generally, only one source at base of TL is used. Conventional pumpers should be placed as close as possible to the TL. If necessary, relay operations should be employed to achieve desired placement of pumper adjacent to TL. When necessary to shut down or regulate pressure, do so of the relay pumper and not the TL-based gate Siamese. Be prepared to move TL for greater effectiveness as conditions change. With proper teamwork, the relocation can be accomplished within minutes. Unless operations can be greatly facilitated, do not use TL as a standpipe. This immobilizes the unit for other services. TL could be used to stretch line up exterior with engine company personnel line, latch into building and engine operations, commerce freeing TL for other operations. When stretching 3.5 line to TL Siamese, stretch male end to TL whenever possible to avoid need of extra fittings and time loss. Whenever possible and conditions permit, water supply to TL shall be from pumper and water sources other than supplying the first due companies and hand lines. All hose connections in TL shall be spanner tight to avoid leakage. I have no idea what any of that means. Conclusion. This section has introduced the primary apparatus of ladder companies currently in service. At any incident, one of the initial objectives is to properly position the incoming ladder company apparatus due to aerial tower ladder capabilities and the need for portable ladders and tools to be in approximately of the incident. Since it's so important to achieve this objective, it's equally important that the members operating are familiar with operation as well as capabilities limitations of the apparatus.